class I was explained about the what are the topics you having in your first unit. Operational up to hexagonal shaped cells I was explained in last classes. Next I will continue. The next topic is the analog and digital communications. So up to this I covered last classes hexagonal shaped cells. Now I am going to explain about analog cellular systems. So analog cellular systems basically in cellular mobile system, the first generation we having the analog radio technology. So in that radio technology, analog radio technology, we having the analog cellular system. It consists of basically three elements. What are the three elements? Mobile telephone, that are mobile radio, and cell site. The another one is the cell coverage. So these three are the important mobile switching center. So these three are the important elements in the analog radio technology. So this geographic area we can cover in a cell where we can take the cellular system analog radio technology, the mobile telephone communication. First the cell side, it covers the what are the signals belonging to that radio analog radio signals. The coverage area it will cover up to that signals only. Suppose for example it is the 100 kilohertz signals, up to 100 kilohertz only limit. So up to that only the signals will be covered in the radio technology. After that, after 100 kilohertz, suppose we can take 200 kilohertz. So at that time it is the beyond the coverage area, out of coverage area. So out of coverage area means that the signals are not covered in that area. That's why the signals will be very weak. At that time we can't get the calls from the outside call or incoming call, whatever it may be, because of the signals are not covered in the limitation area of the signals, frequency signals. Okay. So another one is the cell site. So cell site means what? We know last classes the cell site, it's having for any cell, it's having one nearer base station. From the base station we can give the signals to the cell, and cell will be received the signals, then it covers the area. So that is the mobile radio technology. In that cell site coverage for any cell, it's having nearer base station. For that base station it's having nearer mobile switching center. From the both of the base station and mobile station, it's having one central office. So here the cell site coverage area, it will be considered from the base station to the mobile switching center. So then it covers the area or not, we can consider by using the signals limitation only. Then we can get the communication link. Next, another one, how we can consider the mobile telephone system means, if it is the cell, is it okay? Or we can consider any landline also. For that also same procedure. Base station, mobile switching center, and another one is the telephone center office. So these three are the important nearer stations for any cell site or landline also. Next, another three elements are, these three elements are integrated in the public switch telephone network. So that first generation is the analog cellular system, that is the mobile radio technology. Next, the another one is the digital cellular systems, where the digital cellular system, it uses the digital technology. What is the digital technology? That is, we having, for example, we can take TDMA, GSM and CDMA systems. These three are considered the digital cellular systems. So where the digital cellular systems, TDMA means time division multiple access, GSM means global GSM means global system for mobile communication. All of you hear my voice, ma? Now okay na? Okay. So I will repeat the previous topic also. Analog cellular system, last class I covered up to the hexagonal shaped cells. Next continuation is the analog cellular system. For analog cellular system, we having the basically three elements. What are the three elements means? We can take the mobile switching center. Another one is the base station. This is the base station, and another one is the radio coverage area. So this is the base station for any cell side base station. For base station, nearly it's having the mobile switching center. Meanwhile, it covers the from base station to the mobile switching center. It covers the coverage area. So for example, we can take up to the 100 kilohertz or 200 kilohertz, whatever, maybe we can take one limit 100 kilohertz. So this coverage area, it covers the signals for this base station. Suppose out of 100 kilohertz means suppose it's having 200 kilohertz. At that time it crosses this area, so it will not cover this. That's why the signals are very weak, then the call will be disturbed. So this is the analog cellular systems. In that we can take the simple integrated elements, or we can consider the mobile telephone, that is mobile radio technology, cell site and mobile switching center. These three are the important terms in the analog cellular system. So how it will covers means every cell site it's having one base station, then it converts into the radio signals and it transfers to the mobile switching center. Likewise here, so base station, this is the cell site, then it converts into the radio coverage area signals, then it converted into the mobile switching center, then we can transmit the signals or receiving the signals. Likewise the procedure will be going on. Next, the mobile switching center, again it will connected to the base station, appropriated base station for the coverage area. If it is the cell, okay, or landline, there is also same procedure. So these three are important terms in analog cellular system. Another one is the digital cellular system. For digital cellular system, here also we have to take three important terms, that are the TDMA, GSM and CDMA systems. So what is GSM? It stands for Global System for Mobile Communication, and TDMA is the time division multiple access. It transmits the signals. So we can develop it in the digital technology in these systems. Next, another one is the, in part 2, you having the, what is the general description of the problem. So general description of the problem means in a, I already explained this all topics also, basically in the introduction of the cellular mobile system. Even though I will repeat it, all of you listen carefully. And here the general description of the problem means, for any cellular system, some important terms you have to remember. What are the important terms? Concept of the frequency reuse, channels, co-channel, interference, reduction factor, the desired carrier to interference ratio, the handoff mechanism and cell splitting. So here I already explained the frequency reuse concept. For mobile radio, cellular mobile radio system, if you want to design, then after designing the technology, even though it's having some disturbances, so that disturbances where it will occur, how we can take the solution or how we can take the remedy for the problems, that we can see here. Okay, first one is the what is the basic major element, frequency reuse concept. What is frequency reuse concept? What is the handoff? I already explained the terms. What is the handoff? When one cell is side of the another cell, the cell moves from one place to the another place. At that time, the cell will be the handoff will be occurred. Okay. Next, what is the frequency reuse concept? Where we can take both cells like 1 and 2 or A or B. The same frequency is used for maintaining the long distances. The same frequency is used for maintaining the long distances. There is a no interference, and at the same time we are using the same frequency. So at that time the frequency reuse concept will be discussed. And another one is what are the different types of the cells we having. So we having the different types of cells are basically we can take micro cell. Micro means it is very small size, that we can take some 0.1 to 1 kilometer top building or any malls or airport likewise. Another one is the macro cell. Macro cell means it considered in rural areas or low power generation, or sometimes cities we can take high power generation. So how we can consider that means by using the distance, or simply we can take 3 to 35 kilometers. So 3 kilometers means that is high power, whereas 35 kilometers means it is the low power, because of when the distance is increased the power will be decreased, then it will be considered simply low power. Next, another type of cell is the pico cell. Pico, micro means 0.1 to 1 kilometer. Pico means 0.01 to 0.1 kilometer. So this considered for offices, and low power means it will be up to the 1 watts power, that is the pico cell. Next, another one is the selective cell. Selective cell means we can take like a angle wise 180 degrees and 60 degrees, that is the selective cell. Another one is the umbrella cells. So here handover and traveling we can consider this umbrella cells. These are the different types of cells. Remember, first one is the macro cell. So how we can represent this? 3 to 35 kilometers, whereas 3 kilometers is the high power, 35 kilometers is the low power generation. Next, second one is the micro cell. Micro cell means it is the 0.1 to 1 kilometer. Example we can take top buildings, malls, airports. Third one is the pico cell. Pico cell is 0.01 to 0.1 kilometer. Example we can take offices, and we have to consider low power generation. Fourth one is the selective cell, that is 180 degrees and 60 degrees. Fifth one is the umbrella cells. So here handover and traveling we can consider. So the next concept is here also frequency reuse concept. You can take this figure. Here in this figure, like P0 and P1, same one cell and another cell. So it will be maintain the long distances. So for this long distances, we can consider the same frequency. So this is the one cell to the another cell, and the distance is very poor distance, and we can maintain there is no interference. And here at the same time we can call as this frequency reuse system co-channel. Co-channel means where the interference is due to the common use of the same channel is called co-channel interference. So this is one cell, this is the another cell, but we are using the common channel. So this same channel we are using here from one cell to the another cell. For this situation, the co-channel interference will be occur. Suppose for example we can take two-way transportation. Where two-way transportation there is no problem. So incoming vehicles are going to one side and outgoing vehicles are going to another side. Suppose there is no way of the one way, two sides, only one way is there. At the time incoming outgoing both are coming in the same way. So there is a problem, there is a disturbance, there is a traffic jam. So traffic jam means when the vehicles are cleared on the road, at that time only it will be traveling easily. That means from KAVALI to Nellore, vehicles are same way, or Nellore to KAVALI vehicles are in also same way. So both are same way traveling. At that time the traffic will be jammed. So we can divide the two ways for from KAVALI to Nellore and Nellore to KAVALI individually. At that time there is no traffic jam. So same way we are considered here when both cells are we are using the common channel, same channel. At that time the interference will be occurs. That interference belongs to the two cells that we can consider the co-channel interference. Clear all of you? So see here. So this is one cell, and here I will give the numbering also for 1, 2, 1 and 3. So these two cells are green color and blue color. Both cells are traveling same channel. At the time the co-channel interference will be occurs. And see in this figure we can remember green color we are using 3 times, and pink color also we are using 3 times, blue color like yellow color. So that means what? Same cluster, in the same network we are using same frequency. So different types of phone calls we are receiving from the one mobile center only. Okay, so what are that? Like Airtel or BSNL. So this is Airtel, this is BSNL, or this is Vodafone. So these three all belongs to same frequency, that we can consider the repeated calls only. So that is the frequency reuse concept. Clear ma? So frequency reuse distance. So here we can take this same channel, common channel. The minimum distance, it allows the same frequency to be reused, but it depends on the number of co-channel factors only. So here we will be using the mathematical expression from center, this cell center to this covering area, this distance length L and this radius R we can consider. So for that L square plus R by 2. So this distance is R by 2 whole square. So this distance and here this distance is equal to R square. So the distance between center of hexagonal and center of hexagonal side is L. Then we can simplify this. So both sides of both sides will be equal to this R square. Then L is equal to square root of 3 into R by 2. And here the cell reused pattern it shows in the figure. So suppose you want to find out the distance between the co-channel cells. So then you can consider the mathematically u axis and the v axis are passing through the center of the hexagonal shapes. So to find the distance of this point, you can take the coordinates of u and v. So that is belongs to x axis, another one is the y axis. The transformation we can consider here from xy coordinates. We can take the distance d square is equal to x square plus y square. Then where x is equal to, again we can take the angle. Why? Already I told the cell different types are there. When selective cell means that is belongs to the 180 degrees and the 60 degrees. And here 30 degrees, and we can selective cell, selected we can select from this cell only. So where, see this figure, we can select in this cell only. For this selective cell we can find out the angle of this. How we can take? Likewise. So for this angle x is equal to u cos of 30 degrees and y is equal to, and here this is y coordinate. This again we consider v point, v plus and both u sin 30 degrees. So then all are substitute in this equations. Finally we can get the distance d is equal to u square plus uv plus v square root of. So this is mathematically we are using. Likewise we are using this distance L is equal to under the square root of 3 into r by 2. If I is equal to number of the cells moving along the u axis, then u is equal to square root of 3 into r into j. So here we can take the j is equal to, what are the analysis, from the analysis we can take number of the cells moving along the v axis, then v is equal to square root of 3 r into j, where I is equal to 0, 1, 2 and so on. So d is equal to, we represented u square and v square. So this is the u square and this is the v square, plus u into v means square root of 3 ri into rj. So simplify this, we can get under the square root of 3 into I square plus j square plus ij into r. So therefore the frequency reuse distance d is equal to square root of 3 k r, where k is equal to this total equation I square plus ij plus j square. So likewise we can find out the distance while you are using the frequency reuse concept. For that reuse factor we can take q is equal to d by r. So d is the distance where r is the radius of the cell. So where theoretically the k value is the, it desired the larger value, and what are the total numbers are channel, it is the fixed value. So while you are using that we can take the general equations are d is equal to function of k1 into c by I. So here c by I is equal to co-channel interference reduction factor. Suppose when the co-channel interference will be occur, when we are using the two cells, for the two cells means co-channel, we are using the same channel. At that time the signals will be disturbed, so the interference will be occur. That interference we can call as the co-channel interference. If co-channel interference, that is a problem. Interference means already disturbance of the signals. So how we can reduce that? By using the co-channel interference reduction factor. So this is the co-channel interference reduction factor. So this factor we define the q is equal to d by r. So this already we derived in the previous one, that is the frequency reuse concept, whereas d is the distance, r is the radius. Already we can take here, we are using the co-channel interference means instead of u and v we can take here k1 and here co-channel interference factor C by I, whereas C is defined as C by I is defined as the C is the co-channel, and by what is the interference means sigma k is equal to I to 1 to I suffix k. So where Q is the co-channel interference reduction factor. When Q is the increases, the co-channel interference will be decreases. So automatically the co-channel interference will be decreases. If you want to separation the function distance, we will maintain the only two factors. What are the two factors? Only C by I factors we have to consider. This T is a function of K I and C by I, where Kn is the number of co-channel interfering cells in the cluster. Okay. And here if there are any we can take this cluster. How many cells are there? 1, 2, 3, 4, 5, 6. So this circle having the 6 co-channel interfering cells. So in this cluster or in this section we can consider this co-channel interference. From this co-channel interference we can go for the second section. This is the second type. So suppose we can take this is the first type and this is the second type. So that means what, more number of the interference will be occur. At the time also we can find out the remedy of the interference. So C by I is equal to 1 by sigma k is equal to 1 to I dk by r whole power minus gamma, that is equal to, where d by r we can define the q factor, q into k whole power minus gamma, where qk is the co-channel interference reduction factor with the kth co-channel interfering cell. So k means more number, like we can consider how many number of the cell types we having, cell size, that we can consider in that. So this is the desired co-channel interference from a normal case in a omnidirectional antenna system. So it will be find the desired C by I for k is equal to 7. So here this we can consider in the another concept. So up to this we can we discussed what are the cells we having means only one type we can take here. Okay, suppose we have to consider here 1, 2, 3, 4, 5, 6. 6 cells are there. So these 6 cells, this is the center one. So from this we will take the co-channel interference reduction factor. So how we can consider this case and also this case is by using the omnidirectional. So omnidirectional means here we have to know about the antenna system. So antenna system means first basically we know the how many antennas are there, in that which antenna we are using. Likewise we will discuss the next class. Okay, clear all of you? I will repeat the topics what we discussed in the class. So analog cellular system, for analog cellular system, base station, radio coverage area and mobile station center. So that means analog cellular system we having the అనలాగ్ సెల్యులార్ సిస్టంలో బేస్ స్టేషను, రేడియో కవరేజ్ ఏరియా, మొబైల్ స్టేషన్ ఉంటుంది. ప్రతి ఒక్క సెల్ సైట్లో ఆ బేస్ స్టేషన్ నుంచి ఆ యొక్క సిగ్నల్స్ అనేవి ఆ సరౌండింగ్ ఏరియాస్, అంటే మొబైల్ స్విచ్చింగ్ సెంటర్ సరౌండింగ్ ఏరియాస్లో ఎంతవరకు అయితే ఉంటాయో అంతవరకు మాత్రమే ఆ సిగ్నల్స్ని కవర్ చేసుకోగలుగుతుంది. అందువలన మనం ఏం చేస్తున్నామంటే అనలాగ్ సెల్యులర్ సిస్టమ్ బేసిక్గా ఫస్ట్ సెల్యులర్ మొబైల్ సిస్టంలో ఫస్ట్ జనరేషన్ కన్సిడర్ చేసినట్లయితే అనలాగ్ సిస్టంలో మనం ఏం చేస్తున్నామంటే ఆ అనలాగ్ సెల్యులర్ సిస్టమ్ని మొబైల్ రేడియో టెక్నాలజీ, సెల్ సైటు, మొబైల్ స్విచ్చింగ్ సెంటర్ 3 ఎలిమెంట్స్గా డివైడ్ చేసుకుంటున్నాము. ఈ సెల్ అనేది ఫస్ట్ బేస్ స్టేషన్ నుంచి సిగ్నల్స్ని ట్రాన్స్మిట్ చేయడం కానీ రిసీవ్ చేయడం కానీ జరుగుతుంది. సో ఆ మొబైల్ స్విచ్చింగ్ సెంటర్ వరకు ఎంతవరకు అయితే సిగ్నల్స్ ఉంటాయో అంతవరకు మాత్రమే అది కవర్ చేసుకోగలుగుతుంది. దాన్ని దాటి వెళ్ళింది అని అంటే అది డిస్టర్బెన్స్ వస్తుంది అన్నమాట. సో ఇది అనలాగ్ సెల్యులర్ సిస్టంలో జరిగేటువంటి ప్రొసీజరు. నెక్స్ట్ డిజిటల్ సిస్టంలో ఏముంటుందంటే 3 సిస్టమ్స్ ఉన్నాయి. TDMA సిస్టము, GSM సిస్టము, CDMA టెక్నాలజీ. ఈ 3 టెక్నాలజీస్ మీద డిపెండ్ అయి ఉంటుంది. నెక్స్ట్ జనరల్గా ఈ యొక్క సెల్యులర్ మొబైల్ సిస్టంలో ఏదైనా ఒక ప్రాబ్లం వచ్చింది అంటే ఏదైనా ఒక ఇంటర్ఫిరెన్స్ ఏదైనా వచ్చింది అని అంటే ఆ ప్రాబ్లంకి మనం ఎలా ఓవర్కమ్ చేసుకొని వెళ్ళగలం అనే దానికి కొన్ని కాన్సెప్ట్స్ని కన్సిడర్ చేసుకుంటాము. అవి ఏమేంటివి అని అంటే ఫ్రీక్వెన్సీ రీయూజ్ కాన్సెప్ట్, కోచానల్ ఇంటర్ఫిరెన్స్ రిడక్షన్ ఫ్యాక్టర్ అండ్ డిజైర్డ్ క్యారియర్ టు ద ఇంటర్ఫిరెన్స్ రేషియో, హ్యాండ్ ఆఫ్ మెకానిజం, సెల్ స్ప్లిట్టింగ్ అనమాట. సో ఎంతవరకు కవర్ చేస్తాం ఇప్పటి వరకు అని అంటే డిజైర్డ్ క్యారియర్ టు ద ఇంటర్ఫిరెన్స్ రేషియో వరకు కవర్ చేసుకుందాం. సో ఫ్రీక్వెన్సీ రీయూజ్ కాన్సెప్ట్లో ఏమవుతుంది అని అంటే మనం 2 సెల్స్ తీసుకున్నట్లయితే ఆ 2 సెల్స్కి సేమ్ ఒక సెల్ నుంచి ఇంకో సెల్కి సిగ్నల్స్ పాస్ చేయాలన్నప్పుడు కామన్ ఛానల్ని యూజ్ చేస్తే దాన్ని కో ఛానల్ అంటారు. అక్కడ సేమ్ ఫ్రీక్వెన్సీని యూజ్ చేసేదాన్ని ఫ్రీక్వెన్సీ రీయూజ్ కాన్సెప్ట్ అంటారు. అలా చేసేటప్పుడు సేమ్ ఫ్రీక్వెన్సీ కాబట్టి ఏం డిస్టర్బెన్సెస్ ఉండదు. కానీ సపోజ్ అలా కాకుండా ఏదైనా సమ్ డిఫరెంట్ ఫ్రీక్వెన్సీని అలా యూజ్ చేయాల్సి వచ్చినప్పుడు ఏమవుతుందంటే ఆ సేమ్ ఛానల్ ద్వారా వెళ్తుంది కాబట్టి ఇంటర్ఫిరెన్స్ అనేది అక్కరవుతుంది. సో ఆ ఇంటర్ఫిరెన్స్ అనేది అక్కరైనప్పుడు దాన్ని ఎలా ఓవర్కమ్ చేయాలి అనేది నెక్స్ట్ కాన్సెప్ట్. సో ఇక్కడ ఫ్రీక్వెన్సీ రీయూజ్ కాన్సెప్ట్కి మనము రిపీటెడ్ కలర్స్ ఏవైతే ఉన్నాయో అవన్నీ కూడా ఫ్రీక్వెన్సీ రీయూజ్ కాన్సెప్ట్. నెక్స్ట్ ఇక్కడ మనం ఏదైనా ఒక సెల్ తీసుకున్నప్పుడు ఆ యొక్క ప్రాబ్లం వచ్చినప్పుడు ఎలా ఓవర్కమ్ చేయాలనే దాన్ని మ్యాథమెటికల్గా ఇక్కడ మెజర్ చేసుకోవచ్చు. ఎలా అంటే సెంటర్ నుంచి ఒక లెంత్ తీసుకుంటాం, డిస్టెన్స్ ఏరియా ఎంతవరకు కవర్ చేస్తుంది ఆ కవరేజ్ ఏరియా వరకు తీసుకుంటాం, దాని యొక్క రేడియస్ని తీసుకుంటాం. సో దీన్ని మ్యాథమెటికల్ ఎక్స్ప్రెషన్ ప్రకారము బోత్ సైడ్స్ డిస్టెన్సెస్ విల్ బీ ఈక్వల్ టు ద ఆర్ స్క్వేర్. సింప్లిఫై చేసిన తర్వాత ఆ ఈక్వేషన్ వస్తుంది. నెక్స్ట్ ఇక్కడ ఈ క్లస్టర్లో నుండి ఒక సెల్కి మాత్రమే ఎగ్జాంపుల్ తీసుకుంటున్నాము. XY కోఆర్డినేట్స్కి కరెస్పాండింగ్గా UV ఎలిమెంట్స్ని తీసుకున్నట్లయితే సెలెక్టివ్ సెల్ని మనము కన్సిడర్ చేసుకుంటాము. ఈ సెలెక్టివ్ సెల్ అని ఎందుకు చెప్పుకున్నామంటే మనం సెల్స్ గురించి డిస్కస్ చేసినప్పుడు సెల్లో డిఫరెంట్ టైప్స్ ఉన్నాయి. మ్యాక్రో సెల్, మైక్రో సెల్, పీకో సెల్, సెలెక్టివ్ సెల్, అంబ్రెల్లా సెల్ అని. సెలెక్టివ్ సెల్ అంటే ఇక్కడ మనము యాంగిల్స్ని కన్సిడర్ చేసుకుంటాము. దాన్ని బేస్ చేసుకొని ఈ యొక్క ఎక్స్ప్రెషన్ని మనము యూజ్ చేసుకున్నాము. ఇవన్నీ కనుక సాల్వ్ చేసినట్లయితే మనకి రీయూజ్ ఫ్యాక్టర్ యొక్క డెరివేషన్ అనేది వస్తుంది. సో దీన్ని Q = D/Rగా కన్సిడర్ చేస్తున్నాము. నెక్స్ట్ ఇక్కడ మనం ఏం చేస్తున్నాము అని అంటే దాన్ని సొల్యూషన్స్ తీసుకుంటున్నాం. నెక్స్ట్ ఎప్పుడైతే ఈ సేమ్ ఛానల్ని యూజ్ చేసినప్పుడు ఇంటర్ఫిరెన్స్ అక్కరవుతుందో దాన్ని కో ఛానల్ ఇంటర్ఫిరెన్స్ అన్నారు. సో ఆ కో ఛానల్ ఇంటర్ఫిరెన్స్ని మనం ఎలా రెడ్యూస్ చేసుకోవాలి అని అంటే ఈ రిడక్షన్ ఫ్యాక్టర్ని యూజ్ చేసి రెడ్యూస్ చేస్తాము. దాన్ని C/I అంటారు. దాన్ని ఇలా డిఫైన్ చేస్తారు. సపోజ్ అది ఒక టైర్లో ఉంటే ఇలా కన్సిడర్ చేసుకుంటారు. 6 సెల్స్ వరకు తీసుకుని దానికి రెమెడీ తీసుకున్నారు. అదే సెకండ్ టైర్లో నుంచి మళ్ళీ పాస్ అవుతూ ఉంటాయి. అప్పుడు అలాంటప్పుడు ఎలా తీసుకుంటారంటే K కో ఛానల్ ఇంటర్ఫియరింగ్ సెల్ అంటే దేనికైతే తీసుకుంటామో దాన్ని సెలెక్టెడ్గా తీసుకుని దానికి కూడా మనము ఆ యొక్క ఇంటర్ఫిరెన్స్ని రిడక్షన్ చేయొచ్చు అని చెప్పనేసి తీసుకుంటున్నాం అనమాట. అదేవిధంగా ఇక్కడ మనము ఈ డిజైర్డ్ కో ఛానల్ ఇంటర్ఫిరెన్స్లో మనం ఏం చేస్తున్నామంటే యాంటీనా సిస్టమ్ని యూజ్ చేస్తున్నాం అనమాట. సో ఈ యాంటీనా సిస్టము నెక్స్ట్ క్లాస్లో డిస్కస్ చేస్తున్నాం. ఓకేనా? థ్యాంక్ యూ.